Okay, hello. My name is Yong, and my other paid name is Ali Imran. Today we're gonna to do a short presentation on our lab assignment. I will start first. There are four questions. I will be handling the question 1 and 3, but Ali will handle 2 and 4. So let's start with the pseudocode first. The question 1 said to write a payroll program that computes employees' gross pay and net pay. An employee who works more than 40 hours per week should be paid at overtime rate, which is 1.5 times the regular rate for all hours over 40. Compute the net pay by deducting 10% of a gross pay if an employee earns more than 1,500 ringgit. So this is a pseudocode. We start by getting the regular rate, the work hours per week. Then then we just put it in a if the work hour per week is less than 40 hours, the gross pay is just the regular rate times the work hour per week. However, if it is more than that or else, gross pay will be regular rate times 40 hours, and we add the remaining hours, which is a work hours per week minus 40. That will be the hours after 40 hours multiplied by 1.5 times the regular rate. Also, we need to compute the gross pay that is more, if the gross pay is more than 1,500 ringgit, the net pay is uh, the 90% of the gross pay, which is deducting the 10%, or else it is just the net pay is same as the gross pay. So we are not required to provide the task specifically set to write the pseudocode and the flowchart. So the pseudocode part is here. I will move on to the flowchart. So it is almost as the same as the pseudocode. We start, then get the regular rate, get work hour per week. Then we use a diamond shape because of the decision. If the gross pay is less than 40 hours, then uh, it is gross pay equals to R times H, and vice versa. And we continue. We have another condition state, which is the same as yes and no question. It's like, you can just refer to the pseudocode. Net pay, if yes, it is more than 1,500, the net pay is deducted 10% from the gross pay. So after that, we will print it, then we will end it. Now, the next question. This question 3, is a quite long question. In general, it is just needing want us to calculate the series resistance, equivalent series resistance, and parallel resistance. For this case, we use the examples giving 100, 200, and 300 ohms. Uh, this is a pseudocode. Although it looks short, but it is quite generalized because the calculation part uh, for now is, I think it's not too, we don't need to get too specific about it. We just need just a general idea of the flow of the programming. So this is pseudocode. We start with reading the resistance value R1, R2, and R3, which is 100 and 200 and 300 if in this example. Then we calculate the equivalent series resistance. Then we calculate the parallel resistance. We print out the respective equivalent resistance. Then we end the programs. Now, this is the flowchart. This is the flowchart. It is just the same as a pseudocode. I think my part is done. Ali, can you continue?
Yes. Wait a minute. Can you hear me, by the way? Hello?
Yes.
Yeah, you can hear me. Thank you. Okay, so for the question one, it, question two, the question is quite simple actually. So, given a Richter scale number, we are supposed to characterize them and then classify them according to this table over here. So it's quite simple, nothing too complicated. So let's look at the pseudocode first. So again, it's just an exact copy of the table provided over here. So we start by reading the scale number, and then if it's less, print the total or damage. Basically, it's an exact copy of the table provided. So there's nothing too complicated over here. And of course, if it's larger than 7.5, catastrophic damage, disaster damage, moderate damage, not very complicated. So that's quite simple. So and here's the flowchart. Sorry for the terrible handwriting, but I think you can guess what it's about. Again, it's literally the same thing as the table, so there's nothing too complicated about it. It checks the value of if it's less, then yes, it prints. If it's no, then it checks for the next value. No, check for the next value and for the next until it goes to 7.5. This is a mistake. It's you notice here there's a yes but no because if it's more than 7.5, it's yeah yeah it's get yeah I think it's easy to understand that one. Okay, let's move on to the next question. So question number four is a bit complicated, but I'll try my best. So write a program to process collection of saving accounts, deposit or withdrawals. So let's start. They ask you to begin the program by reading previous account balance and then read and process each transaction. So I guess I can show you the beginning part of the pseudocode. So let's focus over here. So again, start by reading the account balance. This is the previous account balance, and then read the process. So the process over here is actually a variable. So it prompts the input from the user and it's a number. So again, so as you can see, if it's not zero, it's bigger than zero, it's deposit. If it's smaller than zero, it's withdrawal. So this actually fits in with the question. Negative value is withdrawal, positive value is deposit. So that's the second condition which have been fulfilled, as you can see over here. Now, let's look at the positive value first, the deposit. So to explain this function of deposit, so this is it. So basically, to calculate the new balance, basically just the process which I just explained is a variable, plus the account balance, which is here. So we got the new balance, and then we just set the new balance as the account balance. So basically replacing the value of the old account balance with the new balance. And then of course we print deposit and then print the account balance, just like the question asks. So the deposit part is quite simple. Next is the withdrawal part. So in case the process variable, the number is less than zero, negative, yeah. So initially it's quite simple. The new balance is account balance plus process. In this case, because process is less than zero, it's a negative value. So Basically, it's a subtraction, so you get less than the old account balance. So here's where the if part comes into play. So the question asks, print an error message if a withdrawal would result in a negative balance and do not change the balance. So this is the pseudocode for it. If the new balance is less than zero, it means it's negative, just print error. And account balance equals account balance, which basically means don't change the account balance. It remains the same. So that's the if the account balance is negative. So next up is if it's not negative, then it's just normal. So account balance equals to new balance, the new balance that just subtracted over here. Yeah, over here, and set that as the new account balance. So that's the new account balance. And then that's at the end if, and of course print withdrawal and print the account balance, the new account balance for the withdrawal process. And then for the loop part of the question, use the sentinel value of 0 to signal the end of the transaction. So as you can see over here at number 4 here, we has while process is not 0. So if the process, which is the variable, is not 0, it's either bigger or smaller than 0. So it will do the calculation, and then yeah, once it does the calculation for the bigger or smaller than 0, it will repeat step 3, which is to prompt the user for the input of the process variable. And then yeah, yeah, and then it will repeat the whole thing over here. And then since yeah, yeah, and then it will end while. So if it's 0, it will just skip over to number 5 over here, which is end transaction. So until the user prompts for the 0 in here and here, it will just continue looping forever, essentially. So that's the sentinel value part of the question, and then just end transaction, just end the thing. So let's look at the flowchart. So this is just a translation of the pseudocode to get the account balance. Again, get the account balance. Get the process. Again, it's a variable. Probably should have write that one down over here, but let's ignore that. So again, checks for the condition. As you see, is process 0. If yes, then end immediately. Just skip over. So if it's not 0, then it's is it bigger? If it's not bigger, then it's 0 automatically. So if it's bigger than 0, then just calculate the new balance, replace the account balance with the new balance, print deposit, print account balance, and then just go back over here. This is the on-page connector. Go to this one until it loops. So that's for the withdraw deposit. I mean, and then uh, yeah. So if it's withdrawal again, is basically just the translation of this one. So new balance less than 0, print error, account balance is equals to account balance equal to account balance. Keep the same thing, don't change like the question asks for. Go to the terminal, go back to the create process, and then go back to the end. So is so if it's more than if new balance is less than 0, it's negative. So account balance is new balance, just replace it. And print withdrawal, print account balance, go to the terminal and go to the end. So that's it. Hopefully you can understand it. Forgive my terrible handwriting. So that's it from me. Thank you.
So I think that will be all. Thank you.